Oh. All right, so every quadratic equation that we've graphed so far has been in that format right there, right? Okay. And the only thing that we gain from this format is that that number right there is your y-intercept. Correct? And from the other, and from the b and the a term, we can get our vertex by saying x is equal to the opposite of b over 2a. And then plugging that in, once we have that number, plug that in to find what?
How do you do that, Simon?
Huh?
The plus c, how do you do that? You make two
That-
squigglies and put them together.
You make a fancy
It's like a seagull. It's like a seagull.
That is one version of how we are going to write a quadratic equation. A second version is going to be this. Y equals, and there's going to be an a out front, and then we go x minus h squared, and then plus k. All right, now I know I'm bringing in a bunch of different letters. Don't worry about the different letters right now. But what this does, this is referred to as vertex form. Okay, so this is generally called standard form. This one over here is called vertex form. And it's called vertex form because it tells you just by looking at what the vertex is. In this problem, the vertex is located at whatever this h value is, comma, whatever that k value is. Okay. Knowing that, we should be able to kind of work our way back and forth eventually between both formats. So if we say, let's give you an example here. If I go y equals, I'm just going to let a be 1. So you can write it there or you don't need to write it. And then say x minus 3 squared plus 4. Okay. Our vertex for this particular quadratic equation is going to be located, basically what we do, it's h comma k, but right here, like it's saying negative h, right? So basically what we do, if this is negative h and that was h, then to go from negative h to h, we actually have to take the opposite of it, right? Does that make sense? So this is negative 3. So the vertex is actually going to be, the x value is going to be positive 3. And this is positive k right there. And that was positive k. So we essentially, k value is whatever that is. So if it's plus 4, it would be at 4. If it was negative 4, it would be a negative 4. Okay? So the x coordinate is the opposite of what is in the parentheses. And the y coordinate is exactly what is on the outside of the parentheses. Yes? Because that's the a term. So this a right here, it could be 2, it could be 3. Because if we had like over here, like a 2x squared plus 3x or whatever, if that was the same as this equation over here, the a would be 2. It could be 3, it could be 4. You don't have to put the 1 there because multiplying by 1 is just x minus 3 squared. But eventually some of these questions will have a 2, a 3, a 4 out there in front. So that gives me my vertex. Okay. I'm just going to go through a little bit of algebra here, and this is algebra that we've done in the past. If I take y equals x minus 3 squared and plus 4. And I'm going to go through what we call expansion. I'm going to expand this. I'm going to actually do x minus 3 squared. So x minus 3 squared actually means this, doesn't it? So let's go ahead and multiply that out. Let's FOIL that out. What's x times x? X squared. Okay, x times negative 3 will give me negative 3x. Negative 3 times x will give me negative 3x. And then last times last will give me positive 9. And then plus 4. Okay, so we end up with y equals x squared minus 6x plus 13, correct? Okay. That thing right there, by looking at that right there, do you know what your vertex is? You don't, right? It doesn't jump off the page at you, correct? But that thing is the exact same thing as this. It's just in an alternative format. We did a little bit of expanding and simplifying terms, that kind of thing. That top one that I've got circled around, hopefully you see that the vertex jumps out at you there. It's 3, 4. Okay? If I was working on this one down here, and we'll graph both these here in a moment, but if I was working on this one, if I want to find the vertex, I got to say x is equal to the opposite of b over 2a. So the opposite of b would be 6, right? Over 2a, which would be 2. Does that give me 3? Is that the same x coordinate that we got up here? And if I plug 3 in, 3 squared is 9, minus 18 plus 13. 9 minus 18 is negative 9, plus 13 is positive 4. That's the same 4 that we found right there. Okay? So, what I'm trying to get you to see here is there are alternative formats to our parabolas, okay, our quadratic equations. I'm going to graph both these real quick for us. Y equals x squared minus 6x plus 13. Okay, so that is the parabola using the standard form. Okay. Now, if I type in y equals 1 times x minus 3 squared. Okay, kind of look at it right now. You think I need to move this thing up 1, 2, 3, 4 units so it becomes the red one? Yeah. So I'm going to add 4 and it becomes the red one. So now we see 2 different formats, okay, for the exact same curve. Okay? Why do we talk about this? There's going to be problems, guys, where they ask you graph a parabola that is y equals, let's say, 2x plus 1 squared minus 3. Okay? So if I want to graph this, where is the vertex? Remember, our vertex is always at h comma k. So right now, if we look at the h, so that's negative h, that's positive 1. So what does positive h have to be? See how I highlighted these two things? They're the same thing. I highlighted the sign of the h and the sign of the 1, right? If I say negative h is equal to positive 1, but the vertex is located at positive h, how do I make this positive h right here? Yeah, I got to make the 1 negative, right? So my vertex is at negative 1. Okay, now here, those two things are the same. Because I want k, this is already positive k, equals to negative 3. Positive k goes right there. So negative 3 is the vertex. What's the axis of symmetry? X equals negative 1 is the axis of symmetry. Okay, so if we're trying to graph this on our own, let me get a XY axis in here. Okay, so if we're graphing this thing right now, we would want to find -1, -3. So that's my vertex, right? Now, the one thing about this type of format is that it's a little bit more work to find the other points. If I want to find the y-intercept, okay, when it was in standard form, when we were up here in this standard form, the y-intercept was just a c term, right? Okay, well down here, we don't have a c term. We can't find it that way. We can't just pluck off one of these numbers and that be my y-intercept. We have to know that a y-intercept is on the y-axis, right? And anything on the y-axis, any point that I choose here, is going to have an x value of 0, correct? Any one of these points on that axis is going to have an x value of 0. So if I want to know what the y value is when x is 0, I'm going to go plug 0 in for x, and I'm going to get this thing right here. What's 2 times 0 plus 1 squared minus 3? So I've got to do this first. So 0 plus 1 is just 1, right? Square that, you get 1. Multiply that by 2. You get 2 minus 3. 2 minus 3 gives me -1, right? So when x was 0, right there, you're getting back this -1. That's my ordered pair for my y-intercept. 0, -1. Is that okay? You told me the axis symmetry was x equals -1. So there should be, like our dotted line here, our axis symmetry. So I've got 2 points to make my parabola. How far is that distance right there? If this point here is -1, -3, how far is that distance? If that's 0, 0, yeah, my my axis of symmetry is located at x equals -1. So from 0, 0 to there is 1. So that's 1, that's 1. All those distances are 1. So even when we're down here, that distance is 1. So if I go to the left of the axis symmetry 1 unit, that would put me at -2, -1. And now do you have those 3 points that you can use to graph your parabola? Is that all right with everybody? Okay. Now, what I want to show you, because they're going to ask you to kind of bounce back and forth between vertex form and standard form. If they start me with standard form, so if I go like y equals, let's just say 2x squared minus 6x plus 4. And they asked me to put that in vertex form. Vertex form, remember, is y equals a times x minus h squared plus k. This a term right here is exactly the same as the a term that's over here. So we got to start. We can put a 2 there. Okay? This h term, that's the x coordinate of your vertex, right? Don't we know that that's the same thing as the opposite of b over 2a from over here? So let's take the opposite of b. Your opposite of b over 2a. So the opposite of b would be 6, right? Over 2a would be 4. So we get 3 over 2. Okay? That is what goes, right? That's That's the x coordinate of my vertex. So I go x minus that number. And I'll square it. K, that right there is the y value of your vertex, right? Well, our y value is found for our vertex by taking that number and plugging it in there. So we go y equals 2 times 3/2 squared. The thing that stinks about this is the fractions. I get that. Okay, now the fractions aren't all that terrible because this goes to 9/4 times 2 here. This is going to give me 18 over 2 when I multiply those, plus 4. So some nice cancellation that happens here. This turns into, those are cancel, leave me a 2, so 9/2 minus 18/2 plus 4. Well, 9/2 minus 18/2 is negative 9/2 plus 4. Well, negative 9/2 is negative 4.5, right? If I take negative 4.5 and add 4 to it, what do I get? Negative 0.5 or negative 1/2, right? So that's the K value, negative 1/2. And so I just want to demonstrate here. Now not all these questions, some of them will have fractions. But I just made these values up on the fly, so that's why they're really not all that convenient or nice. But if we graph 2x squared minus 6x plus 4, and then graph 2 times x minus 3/2, that quantity squared, minus 1/2. Are those two things the same thing? Okay. Now, let's cheat a little bit. You want to cheat a little bit?
I want to cheat.
Okay. I don't consider it, if we have tools at our disposal, why not use them? Okay, so let's say that I give you the function. Can everybody see if I type up there? I wish I could make it. I can, I guess. If I go y equals, let's just say 3x squared minus 2x plus, don't write this one down. I just want to adjust. That one's a little bit, okay. So let's say I want you to have that one. Okay. And I ask you to put that in vertex form. Okay. What is so vertex form is going to be this format. A, x minus h squared plus k, right? Okay. What is the a that is in the original one? 3. So that is the same as the a that is right here. Okay? All right. So the h and the k are the vertex, right? Well, what's nice is that we've already got the graph over here of this graph. If I click on that, it tells me my vertex is 2, negative 10. So the h value that I plug in is 2. It's the x coordinate of the vertex, right? And the k value that I plug in is negative 10. And are those two things then identical? So we're able to now construct it for whatever reason they give us. There may be a need to have the expanded version like I started with and to have the vertex form. Okay? Or if they start with the vertex form, it might be necessary eventually to have the expanded form. That's a way to maybe circumvent a little bit of the arithmetic, the actual calculating. Notice that does this one tell me what my y-intercept is? It's 2. Okay, it's the y-intercept is always your C term, right? You can see that over here on your graph that we are at 0, 2. Okay. Does anything in there tell me what my y-intercept is? Does that 2 jump out right there? Doesn't. Okay, so what I want you guys to realize is that when I look at this one, when I look at that one, I have information of my y-intercept. But I don't know what my vertex is. Like I do some arithmetic to find my vertex, right? When I look at this one, I don't know what my y-intercept is, but I do know what my vertex is. Okay? So there's a little bit of a trade-off for having one or the other there. Okay? Does anybody have questions on that?
So it can be a negative algorithm in any of those cases, or does that have to be?
Yeah, it could be. So what happens, and kind of show you, you guys remember talking about lines, like if I take like X and then add A to it, that is going to move it up and down. Okay? It also not only moves it up and down, but when this becomes like a 1, when A is 1, X was originally going through 0, 0, right? Now that point, we can think about it as that point moved up 1 unit, but we can also think about it as that point moved left 1 unit. So when we add something here, it's actually moving it left. So let me show you what happens. So if I have x squared, and then I have x minus a squared, okay? And let's just say right now a is 0. Okay, so I don't know why it colors both those black. It's kind of stupid. All right, so those two things are the same, right? Is that okay? But now if so this is just that x minus h part of that vertex form. If I subtract 1 from it, so this would be x minus 1 right there. Which way did it move that orange graph? To the right, correct? If I go x minus 2, it moves it further to the right, correct? Okay. If my a value is, say, -3. So what would be here? It would be actually x minus a -3. Well, x minus a negative turns into a positive, right? So this would actually say x plus 3 right there. And you see that it moved it 3 units to the left? So, to answer your question, can it be positive or negative? Yes, if it is. So if I have like x plus 3, let's use a different number. Let's use x plus 5 squared minus 2. Okay? We know it's x squared. X squared is kind of that parent graph. That's that simplest one that we can ever create, right? This plus 5, from what I just explained to you, is going to move that parent function 5 units that way. And the minus 2 is going to move it 2 units down. So that my vertex right there is now at -5, -2. Does that make sense? If it's a plus sign there, it moves it left. If it's a minus sign, it moves it right, which is kind of contradictory to what you might think, but that's the way it behaves. Did that answer your question? Okay. We'll stop there for today.